We are on page 80. We did our very, very quick review of what a polygon was. Has to be closed, no intersecting sides, has to be flat, no curved sides. We reviewed our names, triangle, quadrilateral, all those things. And I think throughout today we may flip back to page 79 a few times with all those names and just try to review some of that stuff. But we're going to start doing some math with our angles inside these things. And first, there's something I need you to remember that I'm pretty sure, knowing you people, I'm pretty sure you do remember this. Angles in a triangle. What do all the angles in a triangle add to? Of course. All the angles in a triangle add to 180 degrees. All angles add to 180 degrees. The problem is that's not true in a quadrilateral or a pentagon or an octagon or a nonagon or any of those other shapes. They add to different numbers. And that's a pain. I don't really want to have to learn different numbers for different shapes. So there's a little trick we can do. But I'll let you make sure that's in your notes. All angles add to 180 degrees for a triangle. For a quadrilateral, what we're going to do is draw in what's called a diagonal for our quadrilateral. I'm going to draw a line starting here and going to the opposite corner. We can totally figure this out. Ready? A quadrilateral, well, is really how many triangles? 2 triangles. How many degrees in one triangle? 180. So then how many degrees would I have in 2 triangles? What would we have to, what are you doing, George? Yeah. Well, where did you get 360 from, though? You don't mean divide. You're kind of going in reverse. You're taking the 360 to get the 180. What I want to do, like other people were saying, let's just do 180 times 2. We have 2 triangles here. So I think I want to write down 2 triangles. So the angles add to 180 times 2, which is 360 degrees. And that's really what we're going to do for all of these polygons. We're not going to just know, oh, an octagon adds to this. We're going to try to make some triangles, figure out how many triangles we made, and then do some multiplication. And then once we have that down, then we'll start doing some of those problems where you have like a missing angle over here. Can we figure out what that missing angle is? And it'll be very similar to what we did with the triangles, that we're missing some angles here and there. Okay, in general, what we're going to do. Number 1, we are going to pick an angle and draw in all of the diagonals. We are going to pick an angle and draw in all of the diagonals. And I'll show you that in a moment. There's an order we're usually going to go in to make sure we don't miss any of them. We're going to pick an angle, and we're going to draw in all of the diagonals. So, I called this a hexagon. How many sides is that? 6 sides in a hexagon. I can also just count them. 1, 2, 3, 4, 5, 6. Yeah, 6 sides over there. I want to pick an angle and draw in my diagonals. I'm going to go with this angle over here. I'm going to put a big dot there. Actually, the teacher that I used to teach this class with, remember what she would put, Ms. L? Big smiley face by that angle. And it's actually really important we kind of note which angle we're using. I'll show you why in a moment. But what I'm going to do, I'm going to draw in all of my diagonals. I'm going to go from this point to all the other points, although I kind of don't have to go to this one, because that line's already on my shape. So I'm going to go from here over to there, and then straight across from there to there, and then from there down. And I don't have to do that last one because, again, it's right on the side already. What is really important, though, is that you don't start doing this from like over here and then switch and start drawing diagonals from somewhere else, because then they'll make other kinds of shapes and our trick won't work. How many triangles did that make? 4. And it is important to realize, A, you're not using the number of diagonals. I did 3 diagonals, but I don't care about that. I care about the 4 triangles. And also, it's important to realize we're not going to use the 6 from the 6 sides. I need to actually count triangles that I see. We're going to multiply the number of triangles by what? How many degrees in one triangle? 180. We're going to multiply the number of triangles by 180 degrees. Multiply the number of triangles by 180 degrees. So, what did you tell me again? How many triangles over here? 4. What do the angles in a hexagon add to? Well, you need to go do 4 times 180. And of course, just make sure when you're done, you're good about your little degree signs. Go do it. I have 20 minutes, thank you very much. Sorry, Killian. Yeah, I'm not. 720 degrees? Which again means in a moment, if we know like 5 of the angles but don't know the last one, I can do some addition and then subtraction from 720 to find the last one. We'll save that for a moment from now. I would like to see if you can go handle the decagon. Pick an angle. I'm going to go with this one, but you can start from anywhere. Put all your diagonals in and make sure you're getting them all. I would kind of go in an order, go like around this shape and make sure you get to all those corners and see what we can do. Although I will tell you, I don't really see myself giving you too many decagons to work with in general here, because there's a lot to do there. When you're done, maybe go back and make sure you actually got them all. Make sure all the shapes created are triangles. If they're not, that actually means you missed a diagonal somewhere. Yeah, they do make nice little...
Shells are very...
Oh, there's a whole lot of geometry in shells, absolutely. And when you're done and you've counted, do your multiplication. Let's figure out how many degrees in a decagon. And remember, you're counting those triangles that you see. George thinks 8 triangles. Did anyone get more than 8? Less than 8? Did we get 8? Okay. Eduardo, what problem should I now do? I don't need the answer yet, but what problem should I do? 180 times? Exactly. And actually, since you do have your calculator, why don't you go do that and tell me what you get? Big answer. 1440, 1,440 degrees. Not too bad? You are going to love what we do on the next page. Ready? Exterior angles in a polygon. Cross out the top. Mrs. Reap and I decided it's not important. We don't need to deal with that. Especially because, like, exterior means outside. Do you see any angles outside the shape? Not really. We'd have to, like, add them in, and it doesn't go anywhere. So we're going to skip that part. We're going to go down to the example on the bottom for a heptagon. What is the sum of the, cross out letter B, we're just going to do the sum of the interior angles, the sum of the angles inside. What might, well, first of all, don't say it yet, but we need to figure out how many sides are in a heptagon. If you don't remember, go back to page 79, find that in your table, because in a moment I'm going to ask you and you're all going to say a number. And I would love it if we all said the same number.
This has two names.
It does.
That's what's confusing about it.
And when I ask you, I could use either of those names. So here I'm using heptagon, but other times I might use the other. If I want you to name it, you can give me either name. You think you're ready? I'm going to count to 3. You're going to tell me how many sides. 1, 2, 3.
7.
Oh, good. Heptagon has 7 sides. What's the sum of the interior angles? Well, what might be really helpful for us? Okay, I'm not liking 180 times 7. What would be really helpful? How did we do this on the previous page? How do we do it here? I think it would be really helpful to actually see a heptagon. So that's what you need to do. You're first going to draw a heptagon. And by the way, the whole triangle thing will work a lot better if we make it a convex heptagon where we don't have any of those indents. We talked about those before the break. Let's make sure we have 7 sides, draw it, and then once you have it drawn, do your diagonals, do your triangles, do your times 180. So let's try to draw a 7-sided shape. If you feel like it would be easier to not use the ruler, that's okay. Another thing that I will suggest is it might be easier, rather than starting with the sides, to maybe start with some points where the angles are going to go and then just connect them. Because it's sometimes tough to make sure we fit all 7 sides in there. Okay, so I've got my heptagon up there. Make sure yours actually has 7 sides. Then go do your diagonal thing, count the triangles, times 180. I think it shouldn't quite be in the thousands. I think it should be a big number, but not in the thousands. Hold up fingers, George. It's not 5. Oh, I get what you're holding up fingers for. Yes. Can you try to show me? I don't even know what. Never mind. How many triangles? Anyone? Everyone? 5. Killian, have you finished this problem?
Yeah.
What do you have for the sum of the interior angles? 900 degrees, I like it. 5 times 180, we're going to get 900 degrees. This is what half of your homework will look like. Although I think I have the shapes already drawn for you, so you just have to put the diagonals in, count the triangles, times 180. And I think it may also ask you to name the shape. It won't give you the name, it'll just give you the shape, and you'll say, oh, 7 sides, heptagon. And what I'd suggest you do while you're doing that is you go back in your notes to page 79 and make sure you have that table in front of you. The other half of the homework, though, will involve us using this to find some missing angles. So I want to go to page 82. We actually only have 2 more examples we're going to do in the notes. 53. I got 10 minutes, which is plenty. I got 10 minutes, which is plenty. Thank you, Killian. Okay, I want to find that missing angle. And actually, there are 2 parts to all these problems. The first thing we have to do is figure out what all 4 angles, including the one I don't see, will have to add to. This has nothing to do with those angles we have there and everything to do with what we were just doing. I would like you to go draw in your diagonals, count your triangles, and do triangles times 180. Ignore those numbers in there for now. I think I'm probably going to start from the angle that's not marked just because there's some space there. Oh, and actually, can you only make 1 diagonal? That's kind of nice. Go do your triangles times 180, and then we'll do something else with that. Melanie, what will all the angles in a quadrilateral add to? Yeah, because 180 times 2, exactly. 180 times 2, this is going to add to 360 degrees. Well, help me out and think for a moment. You know 3 of the angles, you want to find the last one. And I know all of them are going to add to 360. What do we have to do? George, what do you think? Yeah, that sounds like the right idea. Let's add the ones we have, and then to find the missing one, we'll subtract that answer from what? We normally do 180, but we're not going to do that here. We're going to subtract from 360. So let's add up the 3 angles we know. Let's add 126, 124, and 65. Lucas, have you added those? Okay, after you do that, let me know what you get. $315, good. So the 3 angles I know add to 315 degrees, but all 4 angles add to 360. So what's my last step? I feel like I hear some people whispering it. We're going to do some subtraction. We're going to subtract this from 360. We're going to do all the angles, including the one I don't know, minus the angles I do know. 360 minus 315. What's your missing? 45 degrees. There we go. So what we need to do in these problems, there's really 2 parts to these problems. Part 1, ignore those angles in there. Let's just figure out what all the angles will add to by doing our diagonal thing. Triangles times 180. Okay, we've got that answer. Then, let's add up the ones we have, and we'll subtract that from the sum of the interior angles, from what our 180 times the triangles gave us. Let's try this with the, what is this, by the way? Yeah, absolutely. Hexagon, 6 sides over there. I would like you to, you know what, let's just get our sum of the interior angles. Let's do our diagonals, triangles times 180. Do you need homework? Does 4 look like the right number of triangles? Do you have 4? Good. With the homework, I will be looking for work on these, so just show me the addition problem you're doing, show me the subtraction problem, certainly show me the number times 180 problem. Just make sure you're showing all those pieces. You done, Naomi? What do you have for that missing angle? I like it. Should be 584 when you do your addition. 720 minus 584. Say that one more time. 130. That sounds good. 136 degrees. Do you see how this works? I think I want to do one last problem. And actually, rather than me passing out scratch paper, you can just kind of use the bottom of the page over here. I want to do one last thing. I've got a shape up here with how many sides? 1, 2, 3, 4, 5 sides. So what is that? Hexagon is 6. X for 6. What's 5? Go find it. Page 79 with that table. Why do I feel like only one person is looking things up? Yes, good. Pentagon, there we go. Okay, I would like you to figure out what number is sitting underneath my friend the frog over there. So you're going to need to draw this. And looks like we have 132 degrees, 91 degrees, 142, 92, and then something under the frog. See if you can figure out what the frog's covering up. While you do this, I'm going to come around and pass out the homework. And thank you for being like extra on this morning. I realize this was a short class, but we got through things, so thank you. Tomorrow, by the way, we add algebra into this stuff. I'm sorry. By the way, okay, so we don't need another copy of that. I think that is what's under my friend the frog. Yes. Okay. I like it. No, yes, that's good. You. Never mind. You caught that. Yes. Good so far. Whoa. Triangles times 180. How many triangles do you see? Yeah, not number of sides, but triangles. Just make sure that's a 180. It looks like a 190. Okay, added them all up, and then that means you get subtracted from 540. Yeah. So What is it? 83 degrees over there. When you do your 3 times 180, you get 540. Add up what you have, subtract 83 degrees over there. We are going to need calculators and rulers back, and I need to find the remote control so I can stop recording this. Oh, here it is.